So the first question is that we are to calculate. Okay. I guess in our record, okay. Our first task is to determine the maximum, calculate the maximum height reached. Once it's a vertically upward motion, so the object, this will be the path or trajectory of the object. They will just land on the floor after. So the time taken, the maximum height reached, this will be the maximum height from where it was thrown to the point where its final velocity is 0. So this becomes the maximum height h. So h max or h is equal to u squared over 2g. And this is equal to 20 squared divided by 2 times 10. And our answer is 20 meters. So this is the maximum height reached by the stone. Please, are we okay?
Yes, sir.
I. The time it takes to reach the maximum height. Once it's a vertically upward motion. Of course, T will be equal to U over G. So this will be equal to 20 divided by 10, which is 2 seconds. I. The total distance it covers. The stone will cover this distance, then will fall from the maximum height to the ground. So if this is h, let's take this to be capital H. So total distance would be equal to maximum height plus capital H. Maximum height we know 20, but capital H we don't know. So let's determine that. So using but Gideon.
So, don't say the capital is because the height of the tower is
Exactly. So that will be, so the total distance actually will be equal to 40 plus 50, which is 90. Because 40, when the body moves from the maximum height, from wherever it is thrown to the maximum height, and from the maximum height to this point is also, this is 20 plus 20 plus the height of the tower, which is 50. So the total distance it will cover will be 90 meters. Are we okay? Class, are we fine?
Yes, please.
Then IV, the time of flight. Time of flight. The time of flight is the time taken during the whole total distance covered. Of course, we know the time the body would take to move from where it is thrown to the maximum height. That is 2. So we must get the time it would take to move from the maximum height to drop on the ground. Okay. So using h is equal to half gt squared. Because u is 0, ut will be 0. That's why we have this. H is 90. H is 70. 20 plus 50. So this is 70 is equal to half times 10 times t squared. So we have t squared is equal to
5.
70 divided by 5. And class, what is 70 divided by 5?
14.
Therefore, t is equal to the square root of 14. Gideon, what's the
I
square?
don't understand what you got to say. So I don't understand what you're saying.
Oh, but you said it. From the maximum height to this level.
Okay, so
Hmm.
yes,
What's the square root of 14? Class, what's the square root of 14?
3.74.
3.7.
42.
Therefore, the time of flight will be equal to 2 plus 3.742, which will total 5.742 seconds. Another way out is that when the body moves from where the top of the tower to the maximum height and move from the maximum height to this point, the time taken is 4 seconds, right? So if I could get the time it would take to move from here to the ground and add that to 4, it must equally give us 5.7. But that would also mean that I must know the velocity when the body gets to this point. So the velocity here. I know the velocity just when the body drops on the ground. In fact, the velocity at this point will be equal to the velocity, the initial velocity of the body. So the body is going up with a velocity of 20. Meaning when it gets to the same level, the velocity there will also be 20. But we must calculate the velocity just before it drops to the ground. So using v squared is equal to u squared plus 2jh. I can be able to calculate the velocity when the body just drops on the ground. Okay. We are using this point. It can be even both. It can be even both. If I decide to use this one, u at this point is 20. So 20 squared plus 2 times 10 times the height of the tower, which is 50. This is 400 plus 1,000. So we have 1,400. Square root of 1,400. Yes, square root of 1,400. Or who is telling us doing the calculation? Osafu, go ahead.
10 root 14.
Give it to me in decimal.
37.416.
That's 37.416 meter per second. So this is the velocity what the body would hit the ground with. So knowing the velocity, I can use this to determine the time. The time it will take for the body to move from this point, from the top of the tower to the ground. So T would be equal to V minus U over G. Okay. What is V? V is 37.416 minus U is 20 divided by 10. So we have 1.7416. So when you add 1.7416 is the time that will be taken for the body to move from this point, meaning this height 50 meters. Therefore, the time of flight will be equal to this total time, which is 4 plus 1.7414, and that is equal to 5.742 approximately. 5.742, just as we got when we consider the other method. Class, are you okay?
Yes, please.
So there are so many ways to look at this. Okay, your personal question. This time you will solve this, and after that I discuss with you and you will mark yourselves. All right. A ball is thrown upwards on the moon. A ball is thrown upwards on the moon with an initial speed of 35 meters per second. With an initial speed of 35 meters per second. Calculate I. Calculate I, the time taken to reach the maximum height. The time taken to reach the maximum height. I. The maximum height reached by the ball. 21.
Sir, please, can you take the question again?
A ball is thrown upwards on the moon with an initial speed of 35 meters per second. Giovanni.
So did you say on the moon?
Moon, yes, it's on the moon. We are not around on the earth, no.
So meaning that the person throwing it is standing on the moon.
Exactly. So a ball is thrown upwards on the moon with an initial speed of 35 meters per second. Calculate I, the time taken to reach the maximum height. I. The maximum height reached by the ball. The maximum height reached by the ball. Then its velocity 3 seconds after it has been thrown. Its velocity 3 seconds after it has been thrown. Take gravity on the moon, J on the moon, to be equal to 1.6 meter per second squared. So gravity on the moon is 1.6 meter per second squared. Yes, Gideon.
Yes. In the question, is there any distance for the moon? Or it was thrown in the moon at a distance of
No, it was thrown from the surface of the moon. The person was standing on the moon.
so there's no distance there.
No. Osavo.
Sir, please, sir, take the gravity on the moon to be 1
6 meter per second squared.
Okay, sir.
So I'm giving you 6 minutes to do this. A simple moon question. So you have 2 minutes more to finish. Your time is up. So I'm going to solve it with you. Then you will be marking yourselves, okay, as we discuss. Class, is that okay? Are you there?
Yes.
All right. So a ball is thrown upwards on the moon with an initial speed of 35 meters per second. So U is 35 meters per second. Then acceleration due to gravity on the moon is 1.6 meters per second squared. We have to calculate the time taken to reach the maximum height. So on the earth and on the moon, because the body will decelerate whenever it is thrown vertically upwards, T is still U over G, which is 35 divided by 1.6. And class, what is 35 divided by 1.6?
21.875.
21.875.
21.875
Seconds.
So mark it. If you got it right, mark yourselves correct. Question 2. The maximum height reached by the ball. Once it's vertically upward motion, maximum height is U squared over 2G. So 35 squared divided by 2 times 1.6. And this is equal to, yes,
382.81.
again,
382.81.
there's the maximum height reached. So 300, yes. Then the last I question. The velocity 3 seconds after it has been thrown. The velocity 3 seconds after it has been thrown. So using V is equal to U minus dt. We can calculate for this, or using V squared equals u squared minus 2gh. We can also calculate for this. If we use the first one, Vs, u is 35 minus 1.6 times 3. And what is, this is 30.2 approximately. Is that correct?
Yes, sir.
Class, did you get that?
Yes, sir.
Or if we want to use this, then we must find h. If we want to find, use equation 2. H would be ut minus half jt squared. So the height after 3, the vertical height reached after 3 seconds. This is 35 times 3 minus half times 1.6 times 3 squared. Plus, what is 35 times 3?
105.
105.
1.3 times, no, 0.8 times 9.
105.
I mean 0.8,
11.2.
11.2.
No, 7.2.
Subtract 7.2 from 105.
$97.8.
97.8. Meaning at 3 seconds, it will cover a vertical height of this amount. Okay, so we can determine the velocity V2 because we have the vertical height. So 35 squared minus 2 times 1.6 times h, which is 97.8. Please help me calculate and subtract. 35 squared minus all that. Oh, you are not talking. Oh, Anita, you are there. Anna.
Good. So please, I got 912.04.
I'm coming. This is 312.96. So subtract. Melda.
So what say the answer?
Okay. 96. Okay, this is 912.04. V therefore is the square root of 912.04. And what's the square root of that, Imelda?
It is same answer, 30 points.
So that is another way of doing the same thing. 30.2. 2 meters per second. Okay. So how many of you scored everything? Show by hands. I mean everything. I have 3 hands, 4, 5. 5 of you. 6. Okay. So I think those ones you couldn't actually solve. You have identified your shortcomings. Okay. All right. Another last question. This time, we are going to apply all that we've learned in solving this problem. So pay attention and then please put the question down. Osafo, your hand is up.
Hey, so it's a mistake.
Okay. All right, so please listen. 2 particles P and Q. 2 particles P and Q Oh, somebody is asking why I am multiplying gravity by 3. We are looking for velocity 3 seconds after the body goes up. And using the first equation, v is equal to u minus gt, you can determine the velocity at any time t. Okay, u is 35. J, gravity on the moon is 1.6 times the time 3. So we are only looking at velocity after a time of 3 seconds. So it's because this is J times t, that's why I multiply 1.6 by t. Janelle, are you okay? Janelle, are you there? Okay. And please, I think this is not so difficult. Okay. Find time again to review it. It's not difficult at all. All right. So 2 particles, P and Q, are each positioned at a height 100 meters above the ground. So this is where, when you are drawing, it's very important. This is the ground. And we have 2 particles, P and Q. They are all positioned at a distance of 100 meters above the ground. So from the ground to where they are, the distance is 100 meters. P is projected vertically upwards. Please, the word projected means thrown.
Please, can you come again?
Gideon, I've not ended though. 2 particles,
Sorry,
2 particles P and Q are each positioned at a height of 100 meters above the ground. And that's what I've drawn for you. Are each positioned at a height of 100 meters above the ground. Now, P is projected vertically upwards. So this particle P is actually thrown to go up. P is projected vertically upwards with a speed of 10 meters per second. So particle P is thrown to go up with a speed of 10 meters per second, while Q is projected vertically downwards. So for Q, it is thrown to go down. While Q is projected vertically downwards with the same speed, projected to go down with the same speed, 10 meters per second. Meaning Q isn't free falling. Once it has an initial speed, Q is projected downward, but because its initial speed is not zero, it is not free falling. Take note. It is not free falling. Okay. So while Q is projected vertically downward with the same speed, calculate the time interval between the arrival of P and Q on the ground. Frank,
Please, is the gravity 9.8 or 10?
I've not ended. Okay. Calculate the time interval between the arrival of P and Q on the ground. The time interval between the arrival of P and Q on the ground. Take the acceleration of both. Take the acceleration of both to be 9.8. So G of P, take 9.8 meter per second squared, and then A of Q to also be 9.8 meter per second squared. Are we okay? So
Yes, please.
calculate the time interval between the arrival of P and Q on the ground. This is just the time difference. The time difference between the time taken by both P and Q to arrive on the ground. Give it a try. Start work. Okay. And here I'll give you about, I think, 8 minutes will do. And it's 11:34. 11:34, 8 minutes. So 11:42, you are stopping work. Start work. Our time is up. Oh. How far? Class, how far have you gone? Have you been able to solve it? Hello, give me feedback. Have we been able to solve the question?
No.
Giovanni, Emelda, Asafo, and Co.
Sir, please, you are still on it.
So you want more time?
Need help.
Yes,
Yes,
please.
sir.
Okay, 5 more minutes. I've added 5 more minutes. It's an application of what we've done. Vertically upward and then downward. We are combining the two. So P is projected vertically upward first. So initially, if there is a ground, both P and Q are initially at a height of 100 meters. This is P, then this is Q. Then P goes up, reaches the maximum height, and then drops. So we are calculating for the total time taken for P to move from here with a velocity of 10 meters per second. Okay, and then come here. Then Q, on the other hand, is projected with the same velocity, 10 meters per second. So the time taken to move from here, so it drops. Okay. So the time interval is the difference between the time of flight of both. The difference between the time of flight of both. For P would go up just to a maximum height before it returns. So the time taken for P to reach the maximum height, this will be simply 10 over 9.8. Okay. And this, Priscilla.
Sir, please, are you writing?
Priscilla, I'm listening.
Please, are you writing? Sir,
I
was asking, are you writing?
Yes, I am. You can see.
Yes.
Please, is it everybody? Hello? Class?
Sort of.
Is the board clear or is the writing readable on the screen?
Yes, please.
Yes, sir.
Priscilla, then I think
Yes.
it's a problem from your end. Rejoin, okay? Rejoin. So if you can't see, please rejoin. Augustine and Frank. So the time taken for P to reach the maximum height would be equal to that. And what is 10 divided by 9.8? That is 1 point. Let's not waste time. Oh.
02.
1.02.
Okay. So it would take P this time to move from where it is thrown to the maximum height. Then let's determine the time taken to move from the maximum height to the ground. But before that, we need to determine this total height. Okay. This total height. We have the height of the tower. So H max is U squared over 2G. And we have 10 squared, which is 100 divided by 2 times 9.8. And this is 100 divided by 19.6. Please, what is 100 divided by 19.6?
5.1021.
Okay. What it means is that there's the maximum height is this. 5.102. So the total height from the maximum height to the ground, this will be 105.102. Okay, so this will be equal to U is 0, so half J T squared. And so T squared is equal to 105.102 times 2 divided by 9.8. Please calculate that for me. When we finish, we take the square root. Let's do that quickly, please.
So we should get 210.204 all over 9.8 when you multiply it by the 2.
I want the final answer. So this is 21.45. Okay, 45 seconds. Gideon. Therefore, T is the square root of this. So the square root of this value, what's the square root of this value? Let's respond quickly. Time is not on our side.
4.631.
631 seconds. So it means that the total time for P to drop to the ground is going to be 1.02 plus 4.631. And when you add this, we have a total of, when you add this, we have 1.02 plus 4.631. We have 5.651 seconds. This is the time of flight of P. Gideon. Gideon. Okay. Then for Q, body Q is dropping to the ground. So H is equal to UT plus half JT squared. So 100, H is 100. 100 is equal to 10T plus half times 9.8 times T squared. Okay. Gideon, I keep on calling you, but you don't speak.
I'm sorry, I have this thing. So before you use 105.102, and I thought the 8 was 5.102.
Come again, why did I use?
So before you use 105.102.
The body has reached the maximum height, and so it is falling from the maximum height to the ground. This is already 100. The maximum height is 5.102. So if I'm looking for this distance, Gideon, from the maximum height to the ground, won't you add 5.102 to 100?
Okay, sir. Yes.
Yes. So that's why I added.
Okay, sir. Thank you.
Okay. So this is what we will have. Okay. If we divide through by 2, we have 50 is equal to 5T plus 4.9 divided by 2. This is 2.45 T squared. So use this quadratic equation. Solve it using quadratic equation. Okay. So we'll have 2.45T T squared plus 5T minus 50 is equal to 0. And so use, when you compare to x squared plus bx plus c is equal to 0, A is equal to 2.45, B is equal to 5, C is equal to minus 50. Use the almighty formula to find the value of T. We've done this, so please do it for me right now. B squared minus 4AC all divided by 2A. Substitute and give me the value of T. I mean positive values of T. That should be within 2 minutes 10. Asafo?
Sir, I got negative 50 equals negative 50 plus 10 roots 515 on 49.
No. Then there is something wrong. Check. Asafo, your hand is up again.
Hey, sir, understood.
So you have minus 5 plus or minus square root of minus 5 squared will be positive. So 25 minus 4 times A. A is 2.45. C is negative 50. All divided by 2 times 2.45. And so T would be equal to minus 5 plus or minus whatever is within the bracket will be positive. Because 4 times 2, 5, 4 times 2.45 times 50. This and this is positive. So 2.45 times 4 times 50. This is 490 plus 25. You have 512. All divided by 2 times 2.45. This is 4.9. So we throw the negative away and deal with positive. Okay. So we take the square root of 512. 512. This is 22.63. So 5 minus 5 plus 22.63 divided by 4.9. Okay. So deal with the numerator minus 5, which is 17.63. 17.63, all divided by 4.9. And our answer is equal to 3.597. 3.597 seconds. So there's a time taken for Q to drop. Therefore, the time interval T will be equal to that of Q, that of P, which is 5.651 minus 3.597. That's all. All right. Class, is that okay?
Yes, please.
So our time is exactly up. Giovanni.
Please, I thought U was equal to 0. So why is the
For which one?
for Q?
No. With the same initial velocity. Listen to the question. It never said Q was free falling with the same initial velocity. All right. So if there's no other question, please, if you have question, ask. If you don't have question, let's end here. Your assignment of this nature will come to test your application. Until then, may the good Lord be with you. Take care of you. Please collaborate. If you have concerns, you can send message to me or among your colleagues to address your problem. Okay. Bye-bye to each one of you. Your video will be recorded. It's recorded and will be uploaded as usual.
Bye.
Bye-bye.
Bye.
Bye.
All right. Giovanni, your hand is still up, or it's a mistake?
That is a mistake.
Okay, it better be a mistake. Okay.